Okay, horizontal translations, also called horizontal phase shifts. Again, a bunch of words at the top. I really don't care about the words. Let's take a look at what we're dealing with. So I think we should start with sine x again, and then I think we should graph what they're asking us to graph, which is y equals sine x minus 30. Now, this is what I call inside the function. So it's inside the argument of sine. So this is actually a horizontal shift to the left. No, to the right. So it's a horizontal shift to the right. So if I start off with this curve, what's going to happen is I'm going to do 90, 180, 270, 360. And I think to myself, eventually I'm going to have to shift this to the right 30 degrees. So do I have room to do that? Yes, I do. And this is where it's coming into play, why I leave this extra space. Because I'm going to be shifting it 30 degrees, so I can now tell that each one of these hash marks is 30 degrees. If I had to move it 60 degrees, then it would be 2 of the hash marks. If I had to move it 90 degrees, then it would be moved over 3 of the hash marks. If I had to move it 45 degrees, it would be halfway in between 2 of the hash marks. So that 30-degree segment is really helpful to me. Okay, so now my maximum is 1 in both of them. There's no vertical stretch or anything, so why don't we make it a kind of a nice looking graph. We'll go up to 1 there. We'll come down to -1 there. And the sine curve starts at 0, goes to 1, comes down to 0, goes to -1, comes back to 0. And we get this pretty looking thing. That's the sine curve. That's very nice and dandy, but it's not what they asked for. They asked for this one. So it's a horizontal shift to the right 30 degrees. So this will be 30 degrees here. This is 60 degrees. This is 90. This is 120 degrees. This is 150. This is 180. This is 210 degrees. This is 240, 270. This is 300 degrees. And this will be 390 degrees. So everything moves over 30 degrees. Boom, 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 boom. And you see your new curve has just been moved to the right 30 degrees. And we call that out of phase with the other curve. Now again, this is a physics term, but that's why they call it a phase shift. These are used an awful lot in electronics and all sorts of fields of study. This is why you're taking this course. This is why you're going to be taking grade 12 technical, is because of the trig functions. All right, so there's a horizontal shift. Now what if you needed to do this as a point notation, a mapping? Well, the original one is x sine x. Now this one, you got to sort of think to yourself what's happening here. You're moving to the right 30. So what's actually happening is it's x plus 30. That's movement to the right. Now I know it looks negative and you want to put a negative in there, but it's not. You have to move to the right 30, so you have to take your x value and add 30 to it. And then it's going to be simply sine x is going to be the new one. Is that right? Sine 30, sine x. Let's see if this works. So 0, 0 is going to go to 30, 0, and that did work. See, I don't like point notation that much, so I don't use it that much. I have to make sure it's working for me. Let's see what's happening here. So it's going to be 90 degrees, 1. So 90 plus 30 should be 120, 1. 120, 1. Yes, it did work. So 180, 0 should go to 30 plus 180 is 210 degrees, should go to 0. Did that work? 210 is at 0, yep. 270, -1 should go to 300, -1, and that's that point there. So, and the last one is going to be 360, 0. 360 gets moved to 390 degrees, which is here, and it's going to be 0. So yes, it did work. Notice that this was a horizontal shift, so what was changing were the x's. We didn't change the vertical because there was no a in front of there, and the k didn't change. So I'll stop the video here and I'll be right back.